In this video, I'm going to be going through the 2022 preliminary or Year 11 HSC mid-course review, or the half-yearly, the test that we take about 7 weeks, or in this case it was done after 7 weeks of class time. So, first of all, we have some multiple choice. We're going to go through those, and then we'll go through the extended response. Very familiar question. I stress this all the time as being the most important thing that you need to know in this subject to not embarrass me as someone who did engineering with me. What is concrete? Concrete is made of cement and aggregates. That is D. Okay, which of the following is a method used for producing polymer products? The best answer here is injection molding. Sand casting is metals. Drop forging is typically with metals. TIG welding is typically a way of joining stainless steel and aluminium. Okay, aluminium is used to make drink cans. Which of the following does not describe aluminium? So aluminium is corrosion resistant, it's lightweight and recyclable. It is not generally considered to be brittle. Now, if you had a question like this next year, I'm saying this to the YouTube people, that it's all relative. Aluminium might be considered more brittle than other materials, let's say like compared to lead. But generally speaking, as an engineering property, we would not consider aluminium to be a brittle material. Carbon can exist in multiple forms. This property is so it can exist as graphite and diamond. This property is described as polymorphous. Now, when I marked the tests, I marked something other than B. So that means that there's going to be some adjustment of marks. I just want people to know that before they see their test. So question 4, the answer is going to be B. I'm just going to pause for a sec. The next question, question 5, asks how do we calculate stress? This is the second most important thing you need to know in this subject to not embarrass me, and this question was unchanged from last year's paper. Stress equals force divided by area. Which is not the role of electrical engineers. So electrical engineers are involved in generating, which is making the electricity. Transmission and distribution are how the electricity gets from the power plant to you. Fusion is an archaic word to put water on things or something like that. I just thought it sounded similar enough to use it as a distractor. Identify the material property that describes a material's ability to withstand repeated cyclic loads. That is fatigue resistance. Toughness is impact resistance. Stable at high temperatures is refractory. We're going to say that in a second. Tensile strength, weak strength. Okay, which of the following best describes covalent bonds? So, every year I get kids who choose all of the above. It's like they haven't watched the videos from the previous years where I say that the all of the above there is a trick. I don't know why it's a trick, but I think people tend to think that when they say all of the above that it's almost always all of the above. The answer in this particular case, covalent bonds share electrons. Which of the following best describes oblique drawings? So oblique drawings are the ones that we use when we have detail on one side. So if we only have one circle, or if we're drawing a complex shape that is only on one side, then like say a pentagonal prism, for example. It's a lot easier just to draw the pentagon and then just draw lines at 45 degrees from that. The most natural looking is perspective. Isometric is the one that we can use circle templates, and shows details with multiple drawings from different views is orthogonal. Okay, which of the following is not measured in pascals? Well, pressure is measured in pascals, right? We had under pressure while we listened to we had the film clip with Pascal, and he was under pressure. Strength is another term. Stress is another term for pressure, and strength is a measure of how much a material can withstand stress and pressure. Power is measured in. So we have work is measured in joules, and what is the unit for power? Watts, that's right. Okay, insert Abbott and Costello joke here. Okay, which of the following has a negative charge? Well, metal ions have a positive charge. Protons are positively charged. Photons have no charge, which leaves non-metal ions are negatively charged. Because they've taken on an additional electron, they have more electrons than protons, they have a negative charge. Which of the following is the best description of strength? Okay, so the ability to be deformed is plasticity. Resistance to scratching is hardness. Ability to withstand stress is strength. When we wrote down our definitions, we talked about how Copeland, he says the ability to withstand loads. I don't really like that. I think that it's fine. I would accept it if it was a question where I asked you to fill in the definition. Resistance to fire, corrosion, and other degradation. I would call that durability, even though that's not a term we tend to use in engineering, at least not formally. We tend not to get that as an answer. Okay, semiconductors. I've left out the word use, but no one called me on that during the exam. Semiconductors are used to produce which electrical component? Someone wrote next to their answer, they wrote diodes, and I tell you what, I like that they wrote that. Good for them for writing diodes. I can't give you a mark, though, in a multiple choice. You have to figure out which of these is most like a diode. A diode has 2 layers of semiconductor. A transistor has 3 layers of semiconductor. The 2 layers of diode allow electricity only to flow through one direction, right? Whereas a transistor, the 3 layers allows it to behave like a switch. Capacitors, inductors, and resistors, they don't have semiconductors. Okay, which of the following best describes a refractory ceramic? We've already talked about this before. Resistance to fire, stable at high temperatures is the correct answer there. Easily to cut and form, easily to cut and join, yeah. Okay, again, that should be cut and join, or to be cut and joined. Okay, 30-60 triangle, we've seen these a lot, so what we have to do, we can say, if you don't know how to do trigonometry, I can tell you that if this is 100%, the small side is 50%, the side that's in between is 86.6%, what I call the disco number. If you multiply this number by 86.6, you're going to get a number that's smaller. It has to be smaller because it's the hypotenuse, so we're going to get an answer of 3.6. What is the value of gravity on Earth? 9.8. Right, 9.806, something like that. But we in engineering, we're allowed to use 10. But Alicia Keys, she knows I keep on falling at 9.8 meters per second squared. I said point really funny there, but anyway. Which is the standard for technical drawings in Australia? The AS 1100. It's the only standard that I really talk about very much. I've worked with the other 3 standards. That's why I picked them, because they're all engineering standards, the wind loading, concrete, and bridge design codes. Now, this question 18, I said in the exam that it's 45 degrees here. It's a pretty familiar question. We'd seen this. It's in the 2014 paper, which we talked about. There's a video on YouTube with answers to the 2014 paper. But we had specifically looked at it in class as well. We looked at both of those questions. I'm not going to go into that now because there's so much on there. The last video that I made just before this, or maybe the one before, was on vectors, and you can have a look at the 2014 paper for explanations. Okay, the answer is 298. Which of the following is a thermosetting polymer? Yeah, it's a pretty tough one, this one. Usually by question 19, we're getting to the hardest questions. The idea is that they're supposed to get progressively more difficult. The answer is phenylformaldehyde. Now, some people might say, well, I'm just going to say that's the answer, phenylformaldehyde. We did go through these in the booklet. The other major thermosetting polymer we talk about is polyurethane. We also talk about elastomers, epoxies, and resins being thermosetting polymers. Okay, a diagram shows, now I didn't label the letter P, I should have. Someone asked, and we said this in the reading component of the exam, where point P is acting. So what do we do to solve this? I said before the exam that there would be something on 3/4 methods. Even though I hadn't taught it explicitly, I'd given enough resources. I'd said where to find the book, and that's just so I had some way of differentiating, so that I don't get every kid getting 99 in the test because I give so many of the answers for past tests. How do we solve this? Well, what we know with the 3/4 method is if we have 3 forces in equilibrium, they must either be concurrent or parallel. These 2 forces are clearly not parallel, so it means they're concurrent, which means they meet somewhere. Where do they meet? They meet at this intersection here. So that means that our third force, P, must also go through this point. And then just looking at, if I draw a line between here and there, I get an angle of about 30 degrees, so 27 is the answer we're going to go with. If someone wrote, if this had been an open-ended question, someone had written, what would it have to be, 63, the complementary angle, I would have given that correct as well. I don't care if you measure from north or if you measure from east. I typically measure from horizontal. I think that's a pretty common engineering convention, but I do understand measuring from clockwise, why people would do that. Okay, we've got 6 marks here for describe. This, I think, is slightly new. Normally, I wouldn't ask for this sort of detail, this extensive. Hopefully I'm still recording. I'm just worried that I don't see the number continuing to tick through. We're going to go through it one way or another. Describe one social impact of any biomedical engineering technology. You have to name a biomedical engineering technology. So if you said the cochlear implant, if you said an artificial hip, if you said prosthetics, doesn't matter what you say. And if you said it makes people's life better, boom, I'm going to give you 2 marks for that. So if you said artificial pacemaker means that people live longer lives, I'll give you that. If you said that the sip and puff typewriter allowed people to communicate, I'd give you a mark for that. You just had to identify a technology and describe its benefit. Okay, so the next one is an economic impact of a civil engineering project. A lot of people said Sydney Harbour Bridge, good choice. So what did it do? The economic impact is that it opened up North Sydney, it increased the value of North Sydney property. Right? You could say that it also reduced travel time, therefore reducing the cost of transporting goods. They're the sorts of answers you could give there. There's lots of civil engineering projects. You could say building skyscrapers provides housing. You could say that the Snowy Hydro scheme provided water irrigation for farming, and it also provides electricity, which improves our quality of life. Those sorts of it's economic impact. So electricity, which allows us to run businesses which are going to generate income. The irrigation allows us to grow more crops that we can sell. The environmental impact of any one ITEE technology. iPhones. People buy a lot of iPhones because the technology increases quickly. We have e-waste. E-waste is a problem because we have heavy metals that pollute. I don't need that level of detail. You don't need to explain to me why e-waste are a problem. You don't need to talk about the deforestation of the Congo in the search of tantalum. I'm not asking for that level of detail. I just need you to say computers need batteries. Batteries rely on non-renewable resources. Boom, that's enough. Right? I've only got 2 lines there. I'm not expecting an essay. Okay, in the order that metals were used, the Bronze Age is before the Iron Age. Then we have mild steel was used next. Then we talk about how aluminium was used by the French court of Napoleon III, I'm going to say. Then we have stainless steel, which was used in skyscrapers built in the 30s. Titanium didn't really see use. The Kroll process is actually the latest, but titanium didn't see use until after the Great Depression. So titanium is last. Now, if someone wants to argue that they found a specific resource that contradicts that, I'm willing to look at it. But the thing I'm most interested in is I'm interested in what we wrote down in class, the notes that I provided to you. That's really the basis that I'm using here. Okay, so for the same time, let's have a look at our biomedical innovations. Our oldest are prosthetics, which we have thousands of years old. Then we have X-rays, which are hundreds of years old. Then we have, now in terms of hip replacements and TC scans, there's an argument that they're close enough that I will give it to you in either direction. I'm not going to take marks off. So if you find that it doesn't matter which order you put them in, I've decided I'm going to pay that in discussion. Now, MRIs are different to fMRI scans. fMRI scans are how we can see internal brain activity, and that wasn't until the 21st century. Okay, moving on to mechanics. We need definitions of Newton's 3 laws of motions. These are very commonly tested, and people should be expecting these in their exam. Newton's first law, if you write, I've written inertia, so you can't just write inertia. But if you write something like things want to keep doing what they're already doing, or an object at rest will remain at rest, either of those 2 sentences is sufficient for me to give you that mark. Obviously, you can write a better answer than that, but that is sufficient. Define force, F equals ma, I'll give it to you. Right? Force equals mass times acceleration, I'll give it to you. Define a reaction force. So if you wrote for every action is an equal and opposite reaction, I'll give that to you. Now, reactions, obviously, I give different definitions in the book, but that is such a common answer that I'm pointing that out as equal and opposite reaction. I'm going to give that to you. Now, you'll notice that this is only worth 2 marks. It probably should have been worth 3 marks, but 2 marks is actually really helpful for me. It allows me to be very generous, and it allows me to say, hey, look, that answer's not great. I'm not going to give it to you. Maybe you can pick it up. You've got more opportunities to get that answer. So, because as long as I get 2 of those I'm happy with, I'm going to give you the full 2 marks. So I think that makes me very generous there. Okay, so we're filling out this table. This table has been in every paper I've written for like years now, so you should expect to see some permutation. I do change the values, so you have to actually know all of them. But given that this is something we filled in our notes before we got started, I'm always surprised when people. I understand an occasional error here or there. If you write, say, for instance, I've saw smart people write area is meters cubed. Given that there's so many marks here, there's 13 boxes and only 4 marks, I'd probably give it to you. If that was the only thing you got wrong, I'd probably give it to you. Okay, so area is a scalar. A scalar that is measured in length, in meters, is distance, or I will also pay length. And I have corrected people who wrote length. Velocity is meters per second, and it is a vector. V for vector, V for velocity. Kilograms is the unit for mass, and mass is a scalar. Meters per second squared is acceleration, and acceleration is a vector. N, I will take either force or weight. I will take both, force or weight, and they are vectors. S, seconds, is the SI unit for time. A good one maybe would actually be asked time without giving the unit, because time, the SI unit has to be seconds. You can't write minutes, or I won't give it to you. And time is a scalar. Temperature is Kelvin, right? So I think 1 or 2 people write degrees C. Once upon a time I used to feel worse about that. These days it's in your notes. There's no excuse. And it is a scalar. I think I talk specifically about that in our notes. Okay, screw jacks are inclined planes. 2 students wrote ramps. I like it. It shows that they've got some knowledge, right? That they were thinking they're on the right track. All ramps are inclined planes, but I just don't feel as though a ramp is sufficient for us to give that a mark. A pair of tongs is a lever. I don't care. You don't have to tell me what order of levers. You just need to write a lever. Okay, moving on to materials. So some people did really badly in this section. So I guess I'm going to take this point to say that there are some students who are very good students who didn't do. I'm sure they're going to be disappointed with their results. And this is the area where I think a lot of students did poorly. The first thing I'll say is, did you watch the videos? If you didn't watch the videos, if you didn't look at past papers, you're doing yourself a disservice. I really pushed those past papers on. I printed them out for everyone. That really is something where it gives you a good idea of what sort of questions that are going to be asked. Now, I think that all of these questions or almost all of these questions were changes, but you should be expecting like this question here. I have been using this question for years. I changed the specific items, but you should at this point be able to identify one application for each of these major plastics. I don't have a question here on normally brazing. I mean, I've had questions before about what is the difference between brazing and welding in past questions. This time I'm asking you to actually write about it. Last time I think I asked you to write about what is the difference between MIG and oxy, right? So you should expect something on welding. I won't always have a question on ferrous metals, but you should expect some sort of classification question or some sort of question about groupings. And same thing for, you should expect something on composite materials. Okay, so to move on, brazing. Brazing and oxing both use a flame to join metals. Compare the use of these 2 processes. Okay, so brazing, there's several things you can write. I only need 2. So brazing can be used with non-ferrous metals. You can use brazing to join metals that aren't steel or other iron-based materials. Brazing has a lower temperature. Brazing must be very clean. Brazing does not need to be, it provides a better finish. It doesn't usually need to be machined. It doesn't distort the parent metal, right? Whereas oxyfuel welding, oxyacetylene welding, it uses a high temperature. It distorts the metal. It can only be used with usually steel. It does distort the material and should really only be used on thicker sections of steel. It needs to be machined afterwards. It doesn't need to be as clean. Okay, so there, really I'm looking for 2, answers there, for 2 marks. Okay, compare really means you do have to give a comparison between, so you say, relative to oxy, brazing uses lower temperature. Boom, that's 1 mark. Also, it needs a cleaner surface. Boom, 2 marks. Okay, and you should be able to extrapolate from everything else I've already said. Okay, ferrous metals include these 4 things. What are they in increasing iron content? If you got 1 out of place, I gave you 1 mark. If you got more than 1 out of place, you got 0. So the lowest is wrought iron. Wrought iron has almost no carbon in it. Cast iron has the most. It's got a C for carbon. It's got a C for C for carbon, C for cast iron. It has the most carbon. Then after that, so it's wrought iron, mild steel, high carbon, cast iron. Okay, what are the polymers used? This was answered quite badly for 3 marks. This was a lot of people got this wrong. So polycarbonate is used in car headlights, right? Polycarbonate, right? I really drive that one home. Polylactic acid is used for 3D printing, right? Along with ABS is the 2 main things that we use for 3D printing. The reason we like PLA is because it's biodegradable. PET is used for drink bottles, and I'm sure a lot of people were expecting drink bottles because that was what I'd written in the test previously. In this case, I changed it to fibers for clothing because I said that 60% of polyester is made out of polyester. 60% of polyester is made out of PET. Okay, moving on. Identify 2 methods of producing clay bricks. The answers I'm looking for, the answers that you had in your notes, and I should have said modern engineering methods of producing clay bricks, are extrusion and pressing. If you wrote hand shaping or some variant of that, I gave it to you. Vitrification, I probably didn't give it to you unless I was feeling incredibly generous. This is what, in your notes, it said pressing and extrusion. We looked at the difference. Extrusion has holes. Pressing has what we call a frog, an indentation in it. Yes, you can hand-shape bricks. Because of the fact that I gave people a reference to a podcast about how bricks have been made for thousands of years, I accepted that if someone had used that information, it's technically correct, especially given the wording that I've used here. Compare the application of glass used in windshields and side windows. So car windshields use laminated glass, which is much more resistant to impact. So you can hit a kangaroo without it breaking. It will hold its shape. It will maintain its structural integrity under much greater impact. Whereas side windows are made out of toughened or tempered glass. It's the same thing, just different terms. Toughened or tempered glass, and it will shatter into safe shards in the case of an accident. I'm pretty sure I asked a question pretty similar to this in last year's paper. Maybe it was in the multiple choice and I moved it down to here. Okay, then we have the Airbus A380 is made from fiber metal laminates. Specifically, the one that the fiber metal laminate is glare. What are define 2 properties of composite materials such as glare in aviation with comparison to aluminium? Okay, so compared to aluminium, now you need to write something, but you don't need. I crossed out someone's work to say you don't need to use the top line restating the question. You can just say compared to aluminium, glare is. Has a better strength to weight ratio, has better fatigue resistance, has better corrosion resistance, and it has better fire resistance, right? That's directly from, now you didn't need to write all 4. If you wrote better strength to weight ratio, and better strength to weight ratio and better fatigue resistance, I would give it to you. That's all you need to write. If you just wrote better, if you wrote better, those 2 things, I will give you 1 mark, but you need to say which one has the better strength, which one has. Strength is a bit iffy. You can't just write strength. Now, I had some students who wrote that, glare is tougher. Hey, maybe it is. I'm not a material scientist. I'm not an expert in glare. It's possible that glare is tougher. But if you're writing that down, I'm going to write see me, and you're going to have to come back and you're going to have to show me where you got that reference from. If you wrote it's stronger, well, what does that mean? What kind of strength you're going to need to, like strength to weight ratio, I can pay that. If you just wrote stronger, well, the HSC does not pay stronger. They do not accept the word stronger. Do not write the word stronger. I underlined when people wrote stronger. I don't even really like strength. You need to write what kind of strength, right? So I'm really saying that now, so you're getting a year and a half's worth of repetition here. You need to say what kind of strength it has. In this case, strength to weight ratio. Okay, for this drawing, most people got this right. This actually was answered really well. There were only some people who got one wrong. It is, A is 6, then B is 3. It could have been rotated, but the answer is 3, and C is 7. Answered really well. Describe 2 reasons why sources must be referenced. The simple answer is plagiarism. So we need to know that what work you need to attribute the authors of other people's work, and you need to. It also allows the reader to identify the reliability of the information, to know whether or not we can trust them. So, oh, Jimmy did that. Yeah, well, Jimmy's an idiot. I'm not trusting them. Okay, describe 2 benefits of working collaboratively. Well, you can get more done. You can have a wider range of expertise, and it provides for greater perspectives. Some students have heard me talk about invisible women, and a big problem in design is that we just often don't consider other people's perspectives. Okay, finally we have a drawing. I don't have a good picture of the drawing here. I might have to splice in something at the end of this video to work on that. Okay. So what we're going to look at now is we're going to look at I have 8 different drawings, and I'm going to go from the top left to the bottom right, and we're going to give marks for each of these. Now, it's really important that I stress that the marks for different drawings can be very, very different. I have heard very different things talking to past HSC markers. I think the scale has changed a lot, an enormous amount over the years. 20 years ago, a quarter of the paper was very difficult technical drawings. Now it's sort of 8 marks. The standard that is expected is very, very different to the standard that was expected 20 years ago or more. That said, we can take some general guidance, and I'm going to be a little harsher in my marking here because it's better that as your classroom teacher, better that I'm harsh in my criticism here, because that's going to better prepare you for the HSC. As long as I'm consistent on every question, it's not going to hurt you throughout your year 11 and 12. And what it means is that when you can have a variable level of marking, depending on how many marks each question is, there's less room for markers to award certain things. But in this case, given the fact that the outside lines were already provided for you, so that I'll just quickly mouse over the lines that were provided, 1, 2, 3, 4, and 5. Because that crow's foot and those 5 lines were provided for you, really, you've been given a fairly big head start. So the standard that would be expected for 1 is different to what it would be had you not been provided that crow's foot. If we hadn't provided that as a scaffold, we might say, well, in this case, at least the student has demonstrated that they understand that there's a crow's foot. So they can say, well, at least they understand that the angles all need to be at 30 degrees. Aside from that, when we look at this, not one face is correct, even if it's rotated. So you might say, well, this face here is pretty close to looking like the top view. It's just rotated. Well, the gap's missing. Well, no, you might say, well, that gap was pre-drawn. That wasn't their fault. But this line here is where I can say, yep, I'm confident giving that 0 because even this line here is not drawn at 30 degrees. So at that point, I can say, and it's not just out by a little bit, it's not out by the amounts that this person did freehand and we have to give some tolerance. It's out by enough that I can say this student has not really demonstrated any understanding of what's going on. Okay, so the second drawing is a perfect example. It's not mine, it's a student's, but I have no complaints about this drawing whatsoever. If it's close enough that if it wasn't for a few telltale marks, I would actually think it had been drawn on AutoCAD. Okay, so moving on to the next one in the middle here. Well, it's getting tougher. So here I can say, unlike the other question where I said this is outside the range of freehand sketching, this line here, that's within the range of freehand sketching, and I can say, well, there's something that's pretty close to one face that has been drawn incorrectly, in the wrong location and rotated. The question is that enough? I would say if we hadn't provided the scaffolding, then 100% this would be 1 mark. This student has demonstrated some knowledge. But with the scaffolding, given that these five lines were provided, I'm going to say that it's not enough for me to award the mark. I would call this a 0.4 when I'm in my marking scale, and I would move on. Okay, so lastly we have the top right, and this one here, we can see that we have this front view is correct. Nothing wrong with that. Well, there is something wrong with that, and I'll talk about that now, which is that the lines are not single lines. there are lots of little lines. The term I use for this is feathering, and feathering is not acceptable in technical drawings. Now again, in a different exam, so in the HSC, there might be a 2-mark question, and the markers might say, you know what, this student had very little time under exam conditions. We're going to award marks even if the line quality is terrible. But this is terrible line quality, and it's important that at a year 11 level, and even as a classroom teacher throughout the HSC course, we need to be telling students that this is unacceptable, and that's reflected in our marks. So the line quality here is definitely something that's going to hurt this student. Okay, so the front view is correct, but the top view is incorrect. So the top view, there's 2 separate shapes, they're not joined. This in the middle here is wrong. The side view is wrong. I think a generous marker will give this 1. For me, I'm going to use this as an opportunity to explain to that student that they need to improve the line quality. That probably, hopefully, will have already been explained to them in classroom before this. So this is a time to say that no, there's an expectation and that line quality is not good enough. But a different teacher might give that 1 mark, especially if there was no scaffolding. Yeah, 1 mark would be quite reasonable. With the scaffolding as the question stands, we're expecting something better than that. Okay, so this bottom left, we have the front view is fine, the top view is fine, the side view is completely wrong. And based on that, I can give that 2 marks. The line quality is okay. The angles are more or less okay. They're within the range of what I'm comfortable with. So that's fine. I'll give that 2 marks. The next drawing here, I'm also giving 2 marks, even though the front, top, and side views all look correct, more or less. This corner is actually wrong. It's not an omission. It's actually wrong, and that means that the student has had a misunderstanding of what is going on here. There's a point where they should be able to recognize at a certain point that this line disappearing into nothing is a sign that you've done something wrong, and to reevaluate and to go back and look at the picture. On the other hand, this drawing here, I think this year I was fairly generous and I probably paid this as 2 marks. I drew the line in, and initially I think I marked it as 2, and then I considered that I would say that there was enough knowledge here that I paid it for 3 marks. One of the things I was also happy with this question is that the student has demonstrated a difference in line widths. I can see the difference between this student using a construction line and a firm dark line for their finished drawing, and that makes a big difference. If I couldn't see that difference in line type, if I couldn't see that this student has tried to draw the object and then they've gone over the object with a firm dark pencil afterwards, and they've just left out 1 line, I can understand that, yep, that happens under exam conditions. You can leave a line, and I think it's within reason to still pay that as 2 out of as a very reluctant 3 marks. It's solid 2. I would say it's, I would write in my notes, I'd write this as 2.6, as it's unfortunate that they've made a mistake, but when I look at each of the 3 sides, they are correct, and omitting a line is not the same as drawing the incorrect line. Okay, lastly, we go to bottom right, and here, this is too many omitted lines. I'm happy to give this 2, but I can't give it more than that. So yeah, the front view and side view are correct. The outline of the top view is correct, but the student clearly has, I think they've avoided putting in a line because they're not sure what to do. It could be that the student has run out of time, but either way, I can't give that full marks. So I think that's a pretty good range of what to expect, and hopefully you've learnt some of the things about how we approach where the marking scale is. And what if you take nothing else out of this, remember that lines need to be within reason. I'm happy to allow 15 degrees out, but I can't allow 30 degrees out. And feathering. Feathering is no good. Okay, so that's the paper.